Hey guys, Jay here with Word of Advice TV, and today I want to go over all the furnace components, what they are and what they do. And the reason for that, in my comment sections, a lot of times people call various components different names and they aren't sure what to call them, so they call them whatever it looks like. So I just want to go over all the components, so for people that don't quite know all the stuff in the furnace, this will be more like a little educational session. But before we begin, I do want to point out that a lot of these components do have multiple names. For example, the induced draft motor can be called a power vent motor or just a draft motor, inducer motor. There can be more than one name, so just be aware of that. But anyways, let's begin. We'll take out the top door first. Various furnace doors will come off in different ways. Train doors and American standard doors, they're pretty much kind of spring-loaded like that. I'll take my door off again. So you grab the door handle and you push up and then out. And on some train furnaces, you have to take off the bottom door first and then the top door. Some doors will have screws on them, some of them will have knobs that you have to turn to take off the doors. But getting the doors off isn't too difficult. Once you get the doors off, you see all the components inside of your furnace. I'll start with the junction box, the power switch. This thing right here, the box, is called a junction box. This is basically where your power voltage comes in from the circuit breaker. 120 volts comes into your furnace. And your switch right here, it's like a light switch. If you want to turn the furnace power off completely, you can just flip the switch down. You can also turn off your air conditioner like that. A lot of times customers will accidentally bump that off, or maybe their kids or something, and nothing will work. So that's the junction box. That's where the power comes in. And then right here, we have the inducer motor, the induced draft motor. And the purpose of this motor is to basically suck the combustion gases or the flames through the heat exchanger, which is inside the furnace. It sucks the combustion gases inside through the heat exchanger to basically heat it up so the air that flows through it can get heated as well and get dispersed into your house. So it sucks it through the burners here, through the heat exchanger, and then out your exhaust pipe and out the chimney. 80% furnaces, like I have right here, will be steel vented, where they will have one pipe attached to your inducer motor assembly. As you can see, here's my inducer motor assembly. Here's the motor itself. Here's the inducer motor housing. Different furnaces will have different housings, different inducer motors. Sometimes they will be plastic, sometimes they will be metal, like you see on mine. But 80% furnaces will have a steel vent pipe or exhaust pipe, and 90% furnaces or high efficiency furnaces, they will be PVC vented, so plastic pipes. They will be white or black, and usually there will be two of them. The one hooked up to your inducer motor is going to be the exhaust pipe, and the one that's hooked up to your burners, to the burner box, is going to be your intake pipe. And usually if this motor were to be replaced, you don't just replace this motor part, you actually replace the whole assembly. So this metal part all comes off and you replace it as one piece. Also, there are various different kinds of motors. There's variable speed inducer motors, there's two-stage inducer motors, like mine right here, and there's single-stage inducer motors. The single stage will only have two wires, so they'll have a line voltage, a common, and a ground. But as you can see on mine, I also have a red. That just means that it has two speeds in here for a two-stage motor. And I have a whole nother video that explains how a two-stage furnace works, so if you're interested in how that works, you can check that out. So that's the inducer motor, and like I mentioned before, behind this wall here, we have the heat exchanger, and that's the primary component of the furnace. That is what separates your house air from the combustion gases going out the exhaust pipe right here. And that heat exchanger is usually either tubular, where it snakes back and forth, or it's divided into cells. And like I stated previously, the purpose of that is to divide the house air from the combustion air and also to give off heat. So that heat exchanger heats up real hot and your blower fan is constantly circulating air. That air going past that heat exchanger heats up and it goes out your supply duct, to warm up the rest of your house. And you should also know that high efficiency furnaces, they'll have a primary heat exchanger and a secondary heat exchanger. So they'll have two. And in the second one, there's actually condensation because when the combustion gases cool off enough, they start to condense and create water. So the secondary heat exchanger is actually built to be able to handle water and not rust out. And right here we have a pressure switch. Pressure switches are usually going to be round, like you see on mine. They can be plastic or metal. Sometimes they're going to be a lot smaller than this one. I have two, once again, because I have a two-stage furnace. The purpose of the pressure switch is to prove that we have an adequate draft, or in other words, that my inducer motor is exhausting the combustion gases properly. And the way it does that is through these pressure switch tubes, or hoses. And these tubes are usually attached to either the inducer motor housing or a collector box, if you have one. And as the air is going through the heat exchanger and out the exhaust pipe, there's a pressure difference, and this pressure switch gets closed on a pressure differential, which means this switch here is normally opened up, but whenever the inducer motor turns on and starts exhausting air, that pressure difference that it creates actually closes this pressure switch. And then the electric circuit gets sent through it, and then the gas valve is powered up and the burner's light, and everything goes from there. So long story short, the pressure switch is a safety that makes sure that your inducer motor is properly exhausting all the combustion gases. If it's not, this safety will trip and turn off the furnace so those gases don't come back into your house somehow. So that's one safety. And another safety right here is the high limit switch. A lot of times it'll be rectangular like this. Sometimes it'll be a small little round circular disc. And what this thing does is basically makes sure that the furnace inside is not overheating. So for example, if you have a very dirty filter, if you haven't changed your furnace filter in a long time, that means your furnace will not have enough airflow. So the heat that's building up in the heat exchanger will keep getting higher and higher because the airflow is not absorbing that heat and bringing it to your house. As that heat builds up in your furnace, this switch here will trip and turn off the burners and leave the fan on to cool off the furnace. So this is basically a switch that prevents the furnace from getting too hot. And another safety is the flame rollout switch. I have one right here. I can take the wires off so you can see it better. These are usually manual reset switches, because usually if this switch trips, that means something serious is going on and it could be dangerous. The flame rollout switch is also a thermal switch, just like that high limit that we looked at previously. It also gets tripped from heat. So the reason for this thing is the heat or the flames should all be getting sucked into the heat exchanger. If for some reason your heat exchanger is blocked, or for example the chimney cap on your roof collapses or gets iced over, the exhaust fumes that are supposed to be exhausting out the chimney will start to roll backwards. So your flames are going to start to lick the collector box and kind of roll out backwards. That's why these are called flame rollout switches. So if this box is getting too hot, or if this area is getting too heated, this little thermal switch, the flame rollout switch, will trip and turn everything off. And most furnaces will have multiple flame rollout switches. 1, 2, or 3. In my case, I have 2. One on this side and one on this side. And this here is the gas valve. On different furnaces, the gas valves will look a little different, but for the most part, this is how they look. And the purpose of the gas valve is to open and close and let the natural gas through. So as you can see, this is my gas line coming into the furnace. Usually on the side of the furnace, you'll have the gas shut off pretty close to the furnace. In my case, it's right here. So if I turn that off, that will shut the gas off to the furnace. So that's my gas shut off right there, only to the furnace, not the whole house. And I've been getting a lot of comments about the copper not being code. Just so you know, in my state, at the moment, it is code and it's still allowable. I know in many places they discontinued copper, but here they still use it. That's why when I bought this house, it passed the inspection and everything 2 years ago. But anyways, the gas comes in through the gas pipe right here, goes into the gas valve, and it stops right here. So the way it works is the inducer motor turns on, the pressure switch closes, then the igniter starts to glow, and that's when the control board will tell the gas valve to open. Once the control board tells the gas valve to open, this valve inside will open up and allow the natural gas through. Then this piece right here is called the gas manifold, this black J-shaped piece. The gas will go into here, and on the opposite side, I'll add a picture. On the opposite side, there's these gas orifices. Gas is pushed out through each of these orifices, and then the igniter lights the gas, and all the burners light, and the flames get sucked into the heat exchanger. And I just want to show you the burner quick. A burner quick, I should say. Just so you know how one looks like. On older furnaces, they have ribbon-style burners. They're long, slotted burners. The newer style furnaces have these in-shot burners, which is what I have. And this is what they look like. I'll take one out so you can see. So gas goes into here, and on the opposite side, you basically have a lot of holes, which disperses the flames and makes it into a cone shape. So this is what a burner looks like, and depending on the BTU rating of your furnace, that will decide how many burners you have. Generally, it'll be either 3 or 4 for most furnaces. If you have a big furnace or a lot of square feet, you might have like 5 or 6 burners. But anyways, this is what one would look like. And then right there, that sparkly thing is an igniter. Different furnaces will have different ignition sources, or basically what lights the gas. It can be a spark igniter. The most common is a hot surface igniter like I have right there. Or you might have an intermittent pilot. And a lot of times you'll see a plug like this for hot surface igniters with 2 wires going to it. So in my case, I have a hot surface igniter. So after the inducer motor turns on, the pressure switch is closed. The next thing on the list, the igniter starts to glow bright orange, and then that gas valve will open up and the igniter lights that gas and all the burners light. And then on the opposite side, almost every modern furnace will have one of these. On the opposite side, you have a flame sensor. The flame sensor is just a stainless steel rod. As you can see, mine is a little dirty, and this is actually the most common furnace problem. These flame sensors get dirty because the furnace is sucking air in, because the flames, they need oxygen, so it's constantly sucking air in and blowing it through the burners. And whatever dust and other debris comes in, or carbon from the flames, eventually they coat this flame sensor. And the purpose of this flame sensor, it's another safety device. The purpose of it is to basically turn off the gas if the igniter fails. So for example, if the igniter for some reason burnt out, or for some other reason it's not glowing or not sparking to ignite the gas valve will still open and allow gas to go through. But if there's no flame, this flame sensor is there to shut off the flames so you don't just have gas spewing out. But at the same time, when this flame rod gets dirty enough, it tricks the furnace into thinking that there's no flames, and it shuts the burners off. But if you want to know more about the flame sensor, I have a whole video that goes into depth how this thing actually works. If you want, you can check that out. But that is a flame sensor. It is usually just held in there by 1/4 inch screw, maybe a Phillips. And that's about it for the top section. On the bottom, there's just a few components. Usually you'll have a control board, which will be in front of the blower motor housing. The control board is basically the brains of the operation. It's a printed circuit board which sends power to basically everything. Everywhere you see the wires going, they all pretty much come from this control board. And you can't really see the whole transformer, but all furnaces will also have a transformer somewhere inside the furnace. Many times it'll be on the bottom. Mine is right here. And the transformer basically takes the 120 volts that goes to it and turns it into 24 volts, low voltage. And right here we have a capacitor which stores a charge and helps the blower motor run. You can kind of see my blower motor right there. I'll also add a picture so you can see what that looks like. Inside there's a blower wheel. And actually, if you wanted to take this whole housing out, usually there will be a screw, one here and one on the other side, or maybe in the front. You take those screws out and this whole blower motor housing will slide out. So that housing will usually consist of the capacitor attached to it, the blower motor, the bracket that holds that motor, the squirrel cage blower wheel, and then of course that whole metal housing that houses everything is just one big piece. Well guys, and that is all the components of the furnace. I hope you found this video useful. If I missed anything, please do add that in the comments below so everybody else can learn from that as well. I thank you so much for watching. Don't forget to mash that like button on the way out, and we'll see you next time. And for those of you that watched this video all the way till the end, I want to ask you, have you ever seen an Amish washer and dryer? A retired repair guy asked me that, and of course I told him, no, what is that? And he showed me, and I was pretty surprised. So I bet you can't guess what it is. I'll just go ahead and show you as well. So this is the dryer, and on the other side we got the washer.